what we're going to share today is really maximizing connectivity for critical grid infrastructure, leveraging the 700 megahertz spectrum that many of you have acquired or are looking at acquiring. There are many spectrum options out in the U.S. marketplace for managing your communications infrastructure, but we have extensive experience in the 700 megahertz range, and so we're going to focus in on that for purposes of this conversation today. The overarching mission of our company is to become the world-leading provider of communication solutions and services that leverage both LTE as well as high-capacity narrowband products, which deliver significant value to our customers in enabling secure connectivity management and control of your assets to the edge of your mission-critical and business-critical infrastructure. So with that as an overview, let me give you a quick synopsis of the two organizations that are now Ubiik Mimomax. Mimomax, for those of you who are not familiar, was the company that I came to work for at the beginning of 2020. This was founded in 2007, headquartered in Christchurch, New Zealand, with U.S. offices in Phoenix, Arizona. And Mimomax's mission was to design, engineer, and manufacture the highest capacity narrowband radios in the marketplace, specifically for utility grid infrastructure and public safety communications infrastructure. Those industries that require high reliability, high resiliency, very demanding environments for your radio communications. And we do that across the utility, public safety, government, mining, and other industries as well. Majority of our business has been in the utility space, which is where we're going to focus on today's conversation, but you can certainly see how there'll be some overlap into some other industries as well. And then back towards the end of 2023, we were acquired by Ubiik. Ubiik is a Taiwanese-based firm which was founded in 2016 and has experienced some pretty significant growth. Ubiik pioneered some technology over in Taiwan called Weightless, which was a proprietary wireless solution directed at utilities and helping to manage AMI infrastructure. And now at this point, as an organization with the combined entities of Ubiik and Mimomax, is 150 people strong on several continents. Our most dominant market is the North American market, where we are continuing to expand aggressively. And we have a sales organization and support and logistics around the world. For Ubiik, they are a pioneer, as I said, in this AMI space. They have expanded into the private LTE space because of the success that they had in Taiwan. They've leveraged that experience into the North American market with launching some new innovative technologies that we'll dive into here shortly. And in Taiwan, as the primary leader of AMI infrastructure, they support now upwards of 1 million endpoints for AMI. This is everything from the head-end system to the devices within the meters, embedded Ubiik modules in the meters, and the installation of those across the Taiwanese footprint. So significant experience in that, and you'll see how that will play into the broader conversation around Ubiik Mimomax and the cohesive product roadmap that this now represents. So we mentioned that we were going to focus on 700 megahertz spectrum, and that's important because that is a very well-utilized spectrum within the U.S. utility marketplace. It's incredibly valuable spectrum that also propagates extremely well, which is why so many utilities have opted to acquire that spectrum. And that's where Mimomax has a long legacy of engineering expertise and deployment. Field area networks has been an area that Mimomax has excelled in for years. And these are really, think of these as private, wide area networks built on private grid infrastructure with spectrum that you own, you operate, and you manage that asset. The largest one to date is the Salt River project out of Arizona, which is a project that went on for probably 5 to 6 years before it was finally fully built out. It is the largest referenceable fan in North America. We now have thousands of radios deployed across a very diverse topology there within the Phoenix Basin with both tornado radios as well as Pyxis radios, which we'll talk about here in a few minutes, what those are and what they do. And it's really provided a very cost-effective multi-tier network to provide significant capacity for them to manage their SCADA, their other grid assets for both water and electrical, and was the springboard to many other projects of that nature. Another one that we did was Great River Energy, which is a Northeast utility that supports 28 member-owned co-ops. And again, a very large topography, albeit significantly different than Arizona would be with respect to weather and environmentals. But again, it needed a very robust multi-tiered network These networks are built on basically similar to cellular technology, 360-degree omnidirectional antennas and 3-sector antennas. So you're building a really significant network that can support not only the current applications, but provide scalability for future iteration in that client's network as their needs change, as their topography changes, as their environment changes and the demands of the business. And so that's part of what Mimomax brings to the table, is a very scalable solution for utilities that will last for many years going forward. And as well, expertise that Mimomax has in radio engineering, radio design, engineering, and path and propagation studies to help build and develop the most robust network that's also going to scale and change over time as the customer's needs change. The last one I'll mention again is down in the northwest, or excuse me, southwest, Navapache Electric Co-op up in northern Arizona. This is a network again in the desert, but also some mountainous coverage in some very rural areas. This customer is now expanding into New Mexico and requiring some additional enhancements to their field area network. And their network was really around AMI upgrade as well as SCADA and prioritizing the serial traffic over the Ethernet traffic, which is again some flexibilities that you have as the operator in managing these types of diverse networks leveraging 700 megahertz. So that brings us to the narrowband IoT segment, and where we're going to spend the majority of our time today, because the narrowband IoT is a technology that not only has been maturing over the last few years, but has really started to be, I think, capture a lot of attention from utilities and other industries on the capabilities of what you can do. Most of us know about LTE technology. It's been out there for years now. We've all been using it with our carrier networks with Verizon, AT&T, T-Mobile, et cetera, for years. So now we're looking at narrowband IoT and being able to take a slice of that precious spectrum in 700 megahertz and leveraging it for your infrastructure. Narrowband IoT is a 3GPP certified technology, so it's one of the low power wide area network technologies that you may be familiar with. And I recognize on this call, we probably have people that are at the very beginning of this who are just learning about NB-IoT and private LTE, as well as others who are pretty developed. So I'm going to try to speak to the middle ground if I could, to try to cover everything that would be of interest to either spectrum of where you are in your journey. But LTE, narrowband IoT, is also known as Cat-NB, and this is for those devices that would help you manage your infrastructure with very little bandwidth requirements, but extend your coverage out to the edge of your grid where other technologies may not be able to reach. In addition, it's going to allow for data transfers that would be not nearly as robust as what you would get in a narrowband radio or a 4G technology. However, it is very suitable for some of the applications we're going to talk about and extends the life of your radios and your radio network, and giving you the ability to connect thousands of endpoints on your network as it extends out to the edge, and as it allows you to drive higher capabilities within your network as you're looking at DA, DER, and bringing energy back onto the grid. So all of that is important as you look at the longer term implications of narrowband IoT when you think about where your grid is today and where you want it to be in 5, 10, 15 years. We're really building technology and deploying technology that will help you adapt to the changes that we see going on across the ecosystem. Long battery life is one of the key components of narrowband IoT and low power wide area services. These are devices that may be out there for 10 years before they ever get touched or replaced or have any kind of replacement. So we want to avoid the truck rolls that are so expensive for your business and help you drive up operational efficiency while driving down the costs of maintaining these network assets. And as I said, because of the spectral efficiency of 700 megahertz, it can take as little as a 200 kilohertz wide channel to be able to deploy NB-IoT services within your 700 megahertz spectrum. And that spectrum, by its very nature, penetrates very deeply, so it's really excellent for use of utilities. That is a spectrum that you may be aware sits in between the Verizon 700 mega network and AT&T's FirstNet network. So very precious spectrum, and we have learned over the years of deploying tens of thousands of radios across North America how to best work in those environments sandwiched in between those two carriers. So very successful deployments, and now you can leverage it even further with your investment in that through NB-IoT. So a couple of things just as a primer. And narrowband IoT is band 103, so 700 megahertz as we've talked about. And what this is doing is it's really opening up the ecosystem of providers, from manufacturers to chip makers to other sensor makers to expand the ecosystem and drive the capability that it brings to you as a utility for options. This complements the 700 megahertz deployments that are already in place that we've talked about a little bit, and emerging capabilities that are happening with additional releases of the 3GPP certification standard, which is really the standards body that agrees upon and adopts new technologies. So continuing with that evolution, you've now got releases 14 and 15 and some compelling improvements to the standard that makes narrowband IoT even a better standard, more throughput, lower latency, and longer life of your batteries for those assets in the field. So it's only improving over time. That's really the message there, is this is a standard that continues to improve and iterate over time to help support these applications. So let's talk about that, some of the real world situations that you could deploy that we see customers starting to talk about and starting to evaluate. Distribution transformer monitoring is an area we think has great potential. Providing comms out at these transformers to determine status updates, where there might be overloading or fault indications, anything to help you have more visibility to those assets out in the field and being able to help you manage those assets better is where NB-IoT really can play a role. Certainly EV loading and the adoption of EV is something that most utilities are extensively building out and expanding. I've had 3 meetings this week just with utilities talking about their plans to expand their EVs and expand their solars and renewables as they see more and more demand for this from their customers, both residential as well as consumer or commercial customers. And how do they bring comms out to some of these new assets that are going to require more monitoring and more advisement from a command and control. So transformer monitoring is an area that we think can have real benefits to the business and really drive up the ROI and for these services. Managed charging is another one, as you see more and more incentives, both from federal grants as well as from the industry itself on adopting EVs and hybrid vehicles. The need to have charging at homes and businesses increasing, and that's obviously creating a demand for you to changes in your infrastructure and how you support those customers, the two-way directional energy flow, and being able to shift and balance that demand and load. That NB-IoT can help you in managing those assets that are continually evolving and we know will only grow over time. Remote fault indication. I know I'm probably talking to the choir here because you guys are all utility operators for most of you on the call, but these are areas where bringing additional comms to fault indicators and volt-VAR optimization is really going to be crucial. Low-cost endpoints of communications where you don't have much infrastructure or you need minimal comms, but you need comms there nonetheless. And some things where older technology wouldn't either allow you to have the communications you need or would require you to do a truck roll to find out the status of an outage could be problematic. Mike, are we coming through okay on the audio?
Yes, we're coming through fine.
Okay, terrific. So narrowband IoT could likely cover the SCADA component of this, and it could cover volt-VAR optimization, controllable switches. These are some of the different assets that we see potentially being monitored through an NB-IoT connection. And by very nature, because of the low data requirements of some of these UEs and these sensors, you can have a lot of devices connected to a single base station, and we'll talk more about that momentarily. DER meters is certainly one that most utilities are talking about and investing for. Certain parts of the country are growing this area faster than others, certainly down in the Southwest being the prime example of that. But again, this is allowing you to bring comms where comms may not exist today. In fact, we're doing a lot of pilots and evaluation around AMI monitoring, since that's some of the early success that Ubiik has had overseas. And we believe that some of this technology will fully be implemented within AMI 2.0 methodologies going forward, as many utilities are looking at what does the next iteration of AMI monitoring look like in the years ahead. So applications for narrowband, and this is important to make the distinction between narrowband IoT and narrowband, because this is where the 700 meg spectrum can really serve up multiple use cases for you as a utility. Currently today, the Mimomax narrowband radios can support the field area networks, as we've talked about, both from a point-to-point linking as well as point-to-multipoint. So these are radios that can be highly configurable to your environment. It might just be a single link off of a microwave hop, or a single link to help carry some voice traffic for LMR backhaul, as an example, or it could be something as extensive as a multi-site, multi-city, geographically dispersed field area network that's covering SCADA, backhaul, DA, DER, etc. We've even got radios that have such high throughput and low latency that they're suitable for teleprotection. And when I talk to the operations people and utilities, the control and protection folks, they're like, wait, hold on, wireless for teleprotection? You got to be kidding. Because most of the time they would use fiber if they have an option. But in many cases, fiber is just not practical or it's not feasible depending on where they're at. So we have radios deployed in multiple utilities across the US, serving up teleprotection services for that near real-time communication and getting latency down as low as 3 milliseconds in a 256 QAM radio running in 50 kilohertz channel. So significant improvement over a capability and redundancy required for those critical connections that are required. And then, as I mentioned, the last one here, and this is where we see a lot of suitability in public safety as well as utilities and municipalities, is the voice backhaul services that are required for both analog circuits, maybe to support T1 services or displacement of T1s, or for voice backhaul for P25 DMR services. We do a lot of that across the public safety sector as well as utilities that have LMR networks deployed. So let me give you a little bit of a sense of some of the products that we're talking about so you can have some visual understanding of the types of products that you might see within a given utilities infrastructure. The Mimomax radios, these are what we refer to as the mission critical reliability, the 5 nines reliability that we design to and implement to. And again, this is technology that's been out in the marketplace for over 15 years, thousands of these deployed across North America and now globally. And these are radios that are really engineered to be configured to your environment, to your topology, to the type of use case and scalability that you need as an individual utility. These are not radios that are going to be built off the shelf. They're really built based on the consultation that we have with you up front and taking the time necessary to understand your environment, your linking topologies, your architecture, where you want the radios to operate today, but where you want it to go 2 and 3 and 5 years down the road, so we can help you scale a radio network that supports the emerging needs. We want these radios to be out in your environment for 10 years or longer, so we want to make sure right early on we understand what your requirements are and what the future is of utility. And so these radios will be built and configured to support that going forward. Our flagship product is the Tornado radio. This is a very versatile radio that is built for very demanding environmental standards. In fact, we've got them in cabinets in the desert in Arizona that are not air conditioned, and we've got them out in the field in the Northeast and this Northwest for high mountainous regions, for areas of high snowpack, high mountaintop ranges, etc., and everything in between. These are very robust radios meant to deal with extreme environmental conditions that you might encounter. These are Linux-based radios that have very significant amount of feature sets to them, just a couple of them that I'll mention. These are operated layer 2 and layer 3. We can provide services such as VLANs, quality of service, compression, filtering. I mentioned there's an OPV variant, which is for teleprotection radio specifically. You've got a command line interface as well as a minimal GUI interface. And again, these can be configurable both as point-to-point or point-to-multipoint, and we can also segment the traffic and prioritize the traffic serial over Ethernet. Again, giving you flexibility in your environment to use your spectrum and the radio traffic as you see fit based on your business objectives that's critical to you. These radios can be built in tandem with the high power tornadoes. So the previous tornado operates at 1/4 watt. This tornado is what we call the high power tornado, which operates at 2 watts of power. And this can change a link that was operating at 16 QAM and can bump it up to 256 QAM. So that can really make a link that may not have been viable before, now viable. In fact, I have many of these radios being deployed right now throughout California for California Office of Emergency Services, who uses them for voice backhaul for California Highway Patrol, which is the largest public safety agency in the state of California, because they need the additional length of the path in some of these spots that are high mountaintop sites, obstructed in many cases. And the tornado radios are known because of their propagation and their beam width to be able to support near and non-line of sight applications where, candidly, and oftentimes other radios can't work. Microwave is too expensive, too much tower loading, fiber's not feasible, satellite's not workable, too high of a latency and too intermittent with the communications. Oftentimes, these are radios that will work when no other communications technology will work. So it's important to understand the flexibility of these radios and how they can be managed and monitored according to your environment and your needs. In addition, because high resiliency and 5.9's reliability is something that engineered into the Mimomax radios, these can also be built with 1+1 configurations for immediate failover or switchover in those in radio environments. I have some of these going in right now in a municipality in California, Northern California, specifically for their fire safety comms because they're prone to wildfires and losing their comms. And so they're putting these in with redundancy for the radio links as well as for their antenna operation. So multiple configurations allows you some flexibility within your environment depending on what you have for your infrastructure and what's required for your reliability. Just to give you an example of some of the throughput, this is a little bit of an eye chart, but it shows some of the flexibilities in the radios, being able to adjust the modulation from QPSK to 16 QAM, 64 QAM, and 256 QAM, and the different radio channel widths. Depending on the frequencies that you operate in, the Mimomax radios can operate up to 100 kilohertz wide channels, so it's going to be band dependent. And often in the US, we see a lot of 12.5 and 25 kilohertz. That's what's most predominant. These radios today for Mimomax operate in UHF, the upper band 700 meg spectrum that we're talking about today, but also 800 and 900 megahertz. So lots of flexibility and lots of bands to cover the different scenarios that you might have as a utility and your spectrum positions. So at this point, I'd like to pivot over to the narrowband IoT products because this is a continuation of products both from mission critical now to what we deem as business critical technology. And this is where the new technology and the new acquisition by Ubiik last year really brings this full circle for our utility customers. So GoRAN is a 3GPP certified private LTE narrowband IoT base station specifically built for grid infrastructure. And this is leveraging the 700 meg spectrum that we talked about before. It is available in other bands. We're supporting the Anterix 8 band, which is the 900 megahertz, as well as the Gato and other bands to come. But we see the most potential probably near term in the 700 megahertz band, given the number of utilities that have already deployed this infrastructure within their utility grids. Very flexible base stations. If you saw this in person, this Ubiik base station you're seeing on the screen is about the size of a couple of pizza boxes in size and in depth. And so very compact to be used on infrastructure for pole mounting. In fact, in Taiwan, a lot of this stuff is done in pole mounting residential in facilities where very little infrastructure exists. So very flexible for you as a customer on where this might be mounted. A newer product that we launched recently is a UE, an endpoint, specifically in band 103 to support lower cost radio comms out at the edge of the grid. And this is a perfect device for SCADA, for RTUs, cat banks, switchgear, again, built to the demanding specs of Mimomax with very rugged chassis and capabilities to support these kinds of applications in a lot of different environments. We also, as a manufacturer, provide the modules for these. We have multiple modules that we sell as a part of these solutions that could be embedded into the UE, into a customer's meter. In fact, we worked with Aclara and Itron as two of our meter manufacturers to embed our technology in some of their meters so that they can talk to our GoRAN NB-IoT base stations, and we see more partnerships like that going forward. Again, to support you as the utility customer and your demanding needs as your business changes. So it's important to reference, I think, the 3GPP standards because these are what most utilities have come to know. It's not the wild, wild west, but it certainly feels like it sometimes, given how much new technology is coming at all of us. But because of these are devices that are certified by 3GPP, it really makes the ecosystem much more friendly to manufacturers who can invest time and resource in manufacturing into building products for these. And with some recent releases of the 3GPP standard, specifically release 14 and 15, it provides some additional capabilities that makes narrowband IoT even more efficient. And I think you'll continue to see this evolve over time. So Cat NB2, as an example, will give some higher throughput, both in the uplink and in the downlink. Non-anchoring channels, which we'll talk about here momentarily on the next slide, also helps to transmit more meaningful data to you and your endpoints, to your head-end system. Early data transmission, a feature of release 15, which is also helping to improve the data access when the link goes up and live. It's really maximizing the link for narrowband and Cat-M services, and it also, which is increasingly important, improving the device battery life and reducing the message latency. So, as I mentioned earlier, these UEs that are out in the field are intended to be out there for 10 years or longer. They have to have very low power battery consumption in order to transmit data. So that's a function of the standard that's helping to develop the highest throughput allowed or available in these technologies, while at the same time simultaneously trying to reduce the battery degradation that you're dealing with out in the field. And that will continue to evolve over time through the standards bodies and the improvement of technology. And then non-IP data delivery, which helps to transmit the hex value of the data and not the packet header data associated with TCP and UDP traffic. Again, making more efficient use of the channel that you're using and maximizing the data throughput for getting at the critical data that your business needs to excel. So the non-anchor and anchor channels is really helping to boost throughput. Here's kind of a visual representation of what that looks like. And this will help to optimize the support for the data transmission and helps to get more channels of traffic through this spectrum. Again, maximizing this spectrum because it is such a precious resource and it needs to be utilized and resourced appropriately and also be scalable and dynamic because the needs of your utility we recognize are going to be different from month to month, from year to year. You want to have the flexibility to maximize what that may look like in your environment, and anchoring and non-anchoring of channels gives you some flexibility in the uplink and downlink of that spectrum in order to do that. This is kind of a visual representation of what using your spectrum might look like in a typical scenario, and what we'll talk about here to expand upon further on a hybrid network, and I'll explain what that is in a moment. But this is an example of how we might help to segment a customer's traffic based on their radio network and based on a typical topology for a utility. So using 700 meg spectrum as a guideline, prioritizing your teleprotection services, since those are highly mission critical and priority traffic. The majority of the traffic here, as an example of one of our customers, is for their fan, for their AMI, their substation management, some DA or DER that's coming online, and then taking a segment of that spectrum, a 200 kilohertz channel, dedicating it to narrowband IoT with some spare traffic on the side as business needs change, and allowing you to incorporate these endpoint UEs for running a narrowband IoT network in conjunction with your licensed narrowband network. And so this is an example of how this might look like in a real world scenario for your utility. Again, you're going to be able to adjust this over time. As some assets come offline of your narrowband, you might be able to increase the adoption of narrowband IoT. And so this may be an evolving scale where you're utilizing this spectrum different now than you might a year from now, as you continue to with your grid automation efforts and your grid transformation that many of you are undergoing right now. And also always keeping in mind an insurance policy of having some spare channels available to you for additional traffic or overhead or other things you might need to do within that spectrum. So I want to talk to you for a few minutes about a hybrid network, because this is something that we have been talking about probably since the UBBA show last year. We are members of UBBA as well as UTC and very involved in both of those organizations, helping to support private LTE build out as well as the ecosystem and awareness. And that's really the goal of today's discussion, is to just make you aware and keep you abreast of what's happening within the communication space around the utilities and some of these new capabilities that are coming to light in real world terms. And advantages of a private network is that you're able to run multiple applications across a single network with only one spectrum purchase. And it's going to drive your lower cost of ownership through different network tiers, a higher tier of network radios that would support your high volume traffic, like the teleprotection or the critical SCADA, while also have a secondary tier that may be supporting some of your edge grid technology, your UE endpoints, maybe even behind the meter technology that you need for comms, and just giving you some flexibility as an operator to scale as you see fit. Quality of service and network mission critical applications. I think this is really important, as many of you are running some of your operational technology through the telcos. I came from 20 years of working at telcos, and I can tell you, as good as they are, they're never mission critical, and they're never going to guarantee you in writing with SLAs 5 nines reliability. And so that's something to be aware of, that if you're trying to migrate away from some of those telcos, this could give you the option of doing that slowly over time, and being able to migrate onto a carrier grade network that you manage, where you manage the assets, you manage the radios, and you manage the spectrum of that. You're not having to share it or look through a third party to manage those services for you. So I think having that command and control and being able to be the guardians of your own future is really important as the utility grids continue to adopt and adapt new technology going forward. Full network coverage with flexible deployment and remote access tools. That's some of the unique things around narrowband IoT and narrowband radios. And again, bringing the seal of approval around 3GPP certified and standardized features is going to be important within your environment as well. So given that, we see the adoption happening of both narrowband and narrowband IoT. And what I'm going to share next is in a conceptual diagram of what we have talked to a number of utilities about, and several pilots are going on underway to explore how this might work in a real grid architecture. But this is optimized for a particular utility and what real world conditions might exist. Again, it's going to vary depending on your utility and your topography and needs, but I think it gives a good representation of what you might be able to expect in a real world environment. So you have your head-in system, whether it be your ADMS, your DERM system, etc. You have the Ubiik Mimomax network management platform system, which we manage, which could incorporate now different access methods to that through fiber, through our narrowband radios, as we talked about, running over serial or Ethernet. And then as you move down the slide, moving out in your grid architecture, it could involve some of the narrowband IoT gateways that we've talked about, with either the GoRAN product pictured in the upper left or the Pixis LTE gateway down towards the bottom left part of the screen, that can help you connect different types of assets on your grid based on what your prioritization is and what type of new comms you need to bring into the organization. Again, Ubiik Mimomax can provide the modules, the gateways, the eNodeB private LTE base stations, the antennas. We can really bring the complete solution to you and help on the front end with consulting and advising to help design, engineer these networks with our experience that we've got, both combined with our field area network expertise, as well as the expertise that Ubiik and Ubiik Engineering brings from Taiwan. So really, they complement each other quite nicely, and I think it gives a lot of flexibility to utilities that we're hearing is really leading edge and very visionary from a perspective of communications architecture. As you can see on the bottom of the slide, this can really vary depending on your utility. Some utilities will use these UEs for solar meters, for cap banks, for volt var, like we talked about, maybe inverters in the Southwest where they're capturing lots of solar energy. You might have meter collectors or AMI, or on the bottom right screen, something yet to be determined, something that is TBD for your utility as you support different business operations, and maybe new capabilities are made available 6 months from now that you didn't even know you had 6 months ago. So we think this will provide some added flexibility and a dynamic network that can change over time and really incorporate the best of both worlds for your architecture. Excuse me a sec. So another capability that we have that we're now adding to our portfolio is AI for network optimization. Designing a network for both a FAN or a narrowband IoT network can be a daunting task, but we want you to know we have capabilities to bring significant expertise to bear around AI. We've done AI modeling for years in our networks, and because of what we've done with Ubiik in Taiwan, there's nearly 1 million endpoints that have had over 4 years of modeling done to them around network optimization, and that's now being used to have trained models for RF and data collection from actual deployments, and ensuring that their accuracy is grounded in real-world conditions rather than just theoretical computer-based simulations or environments that you might do on the front end now. We use some of the traditional tools for our radio path planning with maybe mobile radio and path loss, but oftentimes those are just speculative and best world estimations. The AI tool allows us to then also juxtapose on top of that real-world modeling and analysis from a lot of data collected over many years. And so we see this as an ability to help you handle a virtually unlimited number of input parameters based on your unique environment, and using AI and the engines of AI to analyze that data over time to make recommendations and suggestions, again, based on real world environments, real world deployments, and real world conditions on the ground to deal with noise and interference and topography and all the things that you wrestle with as you're looking for radio deployments that are going to give you the best possible outcome. And again, this will change over time and adapt over time as more and more data gets added to the models. But we think this is going to be a very scalable model that will help predictively and post deployment help you maximize your network architecture and can really be a value add to drive up the efficiency of these network models. Harvesting this big data is something we've been doing for years, and we're now bringing it to market as part of our service offering. So again, it'll be real world modeling against some of the predictive modeling that we do on the front end, and the network designs will start with this, but we think it will adapt over time, and through our network management system, we'll have some historical operational stats that will help us be even more keenly aware of where changes need to be made and where there might be hotspots to avoid problems down the road. Millions of data points collected over many years can therefore be ratified and justified in some of these future network designs, giving you confidence that a partner with Ubiik Mimomax can really be the best of all worlds with some of the equipment options that we've talked about. So just one last slide here on AI. I think there's a lot more conversation to be had on this as this product evolves, but it's a very iterative process, as most of you know, and there seems to be a new emergence of AI modeling and AI discussion in the marketplace. And I think a lot of that now is being applied, at least in our space, around network engineering and architectural design to help deal with these very complex, very dynamic networks and conditions that are unique to each of you as utilities. So
20-minute countdown, Dennis.
Okay, thank you, Mike. So I also want to mention that some of our services, which we don't talk about too much, we have a pretty significant services offering that involves project management services. Again, this can augment some of your own existing staff, or in some cases, we can bring staff on site to our utility to help augment their own existing personnel. But some of the things that we do on the front end, and again, as I mentioned earlier in the presentation, we do a lot of time and development up front to have consultative conversations with you on discovering what your needs are, what are your pain points, what's the network you want it to look like, how do you want it to scale, and doing a lot of that predictive pre-sale type of consultation to understand your environment as well as we can. We can assist you with RF coverage design, drive testing, site testing. We can help with, for those of you who need to look at buying more spectrum or what your spectrum options are, we help with that. We have a department that deals specifically with licensing and all of the conditions associated with that. We can even help with manufacturing and integration, cabinet design. These are all services that we've done for other utilities, as well as having personnel that can come on site with you to do training, to do on-site support, commissioning support of radios, 24/7 US-based support, unless it rolls over to New Zealand, but we try to make that US-based as much as possible and being able to get somebody on the line. We also have facilities in Phoenix that can help with logistics and warehousing and bringing stock here into the US market for quicker deployment, as well as managed service offerings that we'll be emerging more into in the future. In fact, one of the things that I failed to mention around the hybrid network discussion is we really think that models are evolving in utilities to where it might be a network as a service option, which is something that we are talking about from several utilities, and making that more of an operational expense for those utilities who are okay with OpEx, or where we would buy the spectrum and then operate the network on behalf of the customer. You operate it and manage it, but we oversee it as a third party. So multiple options. I think the message here is really there's flexibility with Ubiik Mimomax. We really want to do what makes the most sense for you in a long-term relationship and partnership. And for any of you who work with Mimomax in the past, you know that we are very dedicated to customer support and place a high value on serving the customer for the long term. And that's really our goal from the first point of engagement. I wanted to also mention for those who might be going to UTC National here next week, I will not be at this event, but our head of sales, Paul Reed, will be there, as will our CTO, Fabienne Pettigran, and there'll be a couple of breakouts at sessions that they'll be having, so some really good conversation to expand on this discussion that we're having today, or maybe some thought starters that you have that you want to elaborate on at our booth, please consider coming by our booth 10/11 next week, or pulling some of our technology guys aside at the booth to talk about your specific situation, and they can clear up anything that I may have gotten wrong on today's presentation. So there's my backup plan if I've confused anybody with anything that I've shared. So I think that might be our last slide there, Mike. I think I'm going to have you open things back up. We'll have some Q&A that probably have come in during the session, and we will turn that over to you, Mike.
Okay, thank you, Dennis. We do have a couple of questions that have come in. So the first question, how do you connect the different grid devices in this type of network?
So good question. Ubiik offers an LTE gateway, also referred to as a UE, called the Pixis LTE. You may recall that on one of the previous slides. And that can connect your grid assets to a GO-RAN base station via serial ports, RS-485 or 232 Ethernet, to connect your grid assets that way. And there's a lot of UEs that are emerging in the marketplace. We manufacture some of them, but there's a lot of companies that are getting into this space, depending on what kind of devices you need to be deployed or what type of sensors and assets you need managed out in the field.
Okay, thank you. Another question is, how many devices could each GO-RAN base station support?
We get that question a lot, and what I typically say is it depends. And I'm not trying to be evasive. I'm really just recognizing that each environment is different. And we've seen environments where 1,000 devices are realistic, where that may not be realistic in other environments. So it's going to depend on the type of asset being managed, the type of data and throughput, and the topography we're talking about. But it's not unreasonable to expect that you could have 1,000 UEs connected to a single GO-RAN NB-IoT base station in a particular utility environment.
Okay. How or where can you mount a GO-RAN?
So these are very flexible. The GO-RAN units are compact by their very nature and their design, so they can be mounted easily on utility poles, on side of buildings. You can save costs on building new infrastructure. One of the things that we're hearing from utilities is that they like the flexibility of the small footprint in these devices. They're not very heavy, so they don't take a lot of load. And you're going to be environments there. They may be out in the middle of a pole in a farmer's field, potentially, or someplace. If it's a very rural environment, supporting a water or wastewater utility as an example. We've got some customers wanting to do this to manage their dam infrastructure, just to be able to have some visibility to what's going on at their dams. So these can be very remote devices that don't require much infrastructure at all to be mounted. And I should add that the Mimomax radios that we talked about earlier can also be suitable for outdoor applications, and there's other hardware that I didn't talk about that can be outfitting those devices for weatherproofing, for water enclosures, for ruggedized antennas as an example, and different types of mounting options for pole mount, DIN mounting, rail mounting, etc. So a lot of different flexibilities I think that exist for the Tornado products and certainly for the GO-RAN NB-IoT products as well.
Okay, and I'd like to add that for the GO-RAN, it comes with a pole mount option as well as a wall mount option. And then with the Tornado radio family, it has, as Dennis mentioned, a DIN mount, wall mount, as well as a pole mount and a 19-inch rack mount option. Another question is an NB-IoT network running in half or full duplex?
It's actually running in half duplex. It's a HD FDD technology, the narrowband IoT, and these are devices that run in Cat-M and narrowband IoT. And in future iterations, we might be looking at some Cat-1 as well.
Okay. Can the Pixis LTE endpoint enable any edge computing or applications?
They can. The smaller Pixis LTE device, since it's Linux-based, it has an A53 CPU, and that can enable some of the distributed intelligence applications that are on it as well.
Okay, thank you, Dennis. Another question that's come in, how can we quickly test adding NB-IoT to our 700 megahertz network?
Well, that is a great question. We now offer a testing kit with GoRAN, which has an embedded EPC core. I failed to mention that the GoRAN is a flexible base station in that it can have an external core or an internal core, depending on how you want it to be deployed in your environment. And with that GoRAN unit comes an EVK. So it's got an internally embedded EPC, making it plug and play with that evaluation kit. And that EVK has embedded firmware as well, which can automatically transmit both RSRP and RSRQ data with timestamps every 10 to 15 seconds. So a customer can use it for testing. I have several of these right now being piloted in several utilities along the West Coast. And in addition, the EVK also has RS-485 and 232 serial and Ethernet interfaces, so a customer can try to push data from their end devices through GoRAN. I think this is one of these technologies where you really need to see it to believe it, and getting these devices in your bench, on your environment, to really tease them and see through, you test them and see the amount of data and throughput and how they work in challenging situations. I've had a couple of customer conversations where they've just been delighted at the data throughput that they're seeing in what would otherwise be really challenging conditions for any radio hardware to work with. So we're excited about where this is going, and it's getting better all the time.
Okay. Can GoRAN work with our existing EPC?
It can interface with an external EPC through an S1 interface, or an internal EPC, depending on the customer's environment that they might have encountered.
Okay, thank you, Dennis. Another question that's come through is, don't LTE systems require a lot of core network functions like MME, SGW, etc.? Do we need these core functions for private LTE? And I'll take this one.
Okay.
The GoRAN and FreeRAN radios do have a built-in core into each individual radio. So we can offer that as a dispersed core architecture, or we can have a core on the cloud, which would consolidate all that. Our radios do also work with third-party cores, such as Ericsson or Nokia, as well as Druid. If another core is required, we can always test with those, but we should be able to work in all of those different types of functions.
Yeah, thanks for adding that. In fact, Mike, we probably need to have a future slide that talks about some of our partnerships, because that's continuing to grow over time. In fact, we're doing some work with some Canadian utilities up there, and that's bringing more manufacturers to play into the ecosystem as well. A rising tide raises all boats as it relates to NB-IoT, and we want to encourage partnerships with other manufacturers, UE makers, et cetera, to be able to really make these solutions around narrowband IoT and private LTE specifically more attractive to customers to be able to adopt this kind of technology.
Okay. And another question that's come up that I think I'll try to answer is, do the radios support NB-IoT and LTE-M? What is the main difference in terms of applications? We can support both LTE Cat 1, which is at 3 megahertz, and LTE-M, which is at 1.4 megahertz, or NB-IoT, which is at 180 kilohertz. The difference would be the data requirements versus coverage. If you need more capacity, LTE-M would be good, but NB-IoT would provide better overall coverage in the network.
And I should also add, we also work quite closely with the spectrum brokers and those parties who are responsible for making access to available spectrum. So we can assist you in your research if you're needing some assistance in looking at what spectrum might be available to cover your utility grid architecture, and who to go to, what the price points are, and what that might look like in terms of cost to your business. So those are also services that we provide. So you're not in this journey alone. Ubiik Mimomax brings a lot of expertise to help you along the whole continuum of what you might need to consider building out a private LTE network.
Okay, thank you. We're getting close to the end of the session. I would like to mention that up in the top right-hand corner, just to the right of the questions box, there's a materials icon there. So there's some downloads there for you. Additionally, any of the questions that we did not get to, we will be answering. And I'd like to thank everybody for coming to the webinar and attending. I know that it's taken time out of your valuable day. We look forward to speaking with you again.
And just a reminder, we will be recording this session and sending it out afterwards. And again, I also want to echo Mike's comments. Thank you for your time. It's very valuable of you to spend your time with us this morning. We hope this was informative. We hope if you have any questions, feel free to shoot me, Dennis Sullivan, an email, and we'll address your specific questions if we didn't fail to do so today, or you want to share something privately. And as well, please consider swinging by our booth and listening to our sessions next week at UTC National by all accounts. It looks to be a great show. So thank you for your time, everybody. Have a wonderful day. Take care.
Thank you.
Thank you, Mike.